right? We are being given the function of f here. Still, we are to interpret a cubic function, right? This function is given by f at x equals x cubed minus 4x squared minus 11x plus 30. Right, we've got point A, point B, point C. Point A, point B, point C. Point A, it's x1, and then we've got point B again, that is x2, and then we've got point C, that's our x3. So as you can see, I've indicated that y is 0. Y is 0. That means these are our x-intercepts. Our x-intercepts. And then we've got point D out there. Point D, the coordinates are 0 is to y. Point D, which means this is our y-intercept. G and E are our stationary points. G and E are our stationary points. And again, this is an increasing function. It's an increasing function. Right, let's continue to the questions.
The first question, calculate the length of AC.
We are to find the length of AC, and then we've got the next question again.
Calculate the length of EF.
We are to find the length of EF. Calculate the length of AC, find the length of EF. Length of EF, yeah. And then the next question,
Determine the gradient at B.
we are to find the gradient at point D. We are to find the gradient at point B. Gradient of a tangent. We are to determine the gradient of a tangent. At point B. And then let's see the fourth question.
A line with a gradient equal to -11.
A line with a gradient equal to -11. A line with a gradient equal to -11.
Is a tangent to the curve of F.
Is a tangent to the curve of F.
Then determine the X coordinates. Of the point of contact.
The X coordinate of the point of contact.
fifth question. Determine the value of x if
we are to determine the value of x if
negative 7 times gradient is greater than 0.
negative 7 times the gradient is greater than 0. Right, these are our questions that we need to answer here. You calculate the length of AC, the length of AC here, the length of AC. Now we can't use centimeters or millimeters. You need to apply appropriate calculations. When you look here, you've got point A, point B, point C. These are our x-intercept. So you are being given the equation. Therefore, that means you need to find the x-intercept so that you will be able to know each of those x values there. Because these are the x-axis, so the length from A to C, it requires the values of x in each of those points there. So let us firstly find the x-intercepts. Our given equation is x cubed, it's x cubed minus 4x squared, minus 11x, plus 13. f at x equals x cubed minus 4x squared minus 11x plus 13. So in order for us to find the x-intercept, we will have to let y to be 0. After letting y to be 0, we find the first factor using factor theorem. Thereafter, you factorize this equation completely and solve for x. We let y to be 0. Therefore, now our equation will be x cubed minus 4x squared minus 11x plus 30. All these will be equal to 0 since we are looking for the x-intercept. Remember, for the first factor here, we use the factors of 6, including the negative ones. Right. Our first factor here will be x minus 1. Our first factor will be x minus 1. Let's check. No. X minus 5. Right? And then let us now find our quadratic on our second bracket. It's x squared and then 5 times a number, it's 30. Therefore, that number must be negative. Therefore, it's negative 6. 5 times x squared, that's negative 5x squared. We are to move from negative 5x squared to 4x squared. Obviously, we need to add. We add here. For us to have negative 4x squared, we need to add that. Therefore, it will be plus here. It's plus x. And then from there, we factorize this completely. It's x minus 5 into x plus 3 into x minus 2. This will be equal to 0. It's 3x minus 2x to get x. 3 times negative 2, that's negative 6. X times x, that's x squared. Right. As you can see, always we've got the factors of 6 there. Therefore, our x will be equal to 5, or x is equal to negative 3, or x is equal to 2. These are our roots, are the values of x. And then our x-intercept will be negative 3 is to 0. The other one, it's 2 is to 0. And then the last one will be 5 is to 0. Right? These are our x-intercepts. The first point here, it's negative 3 is to 0. This one, 2, let's put f there, 2 is to 0. And this one here, it's 5 is to 0. Right. Using a number line, right, if this was our number line, let's start from negative 3. Negative 3, as you can see there, it's negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6. Right. We are to find the distance from negative 3 to positive 5. The distance from negative